In this tutorial, we'll create an RGB night light using Arduino and Tinkercad. You'll learn step by step how to wire an RGB LED, a photoresistor, and a potentiometer in a virtual circuit. Let's get started. First, open Tinkercad in your browser and log into your account. On the Tinkercad dashboard, click the blue Create icon at the top right, then choose Circuits. This opens up new Tinkercad workspace where you'll build your circuit. Click the project name bar at the top left and rename it to RGB Night Light to keep things organized. On the right-hand side of your workspace, you'll see the Components panel. Make sure to choose All from the Components bar rather than Basics so you can access to all the components. In the search bar there, type Arduino UNO R3. When it shows up in the results, click and drag it into the workspace. Now, we need to rotate it to match our preferred layout. In the toolbar above, you'll see the rotate buttons. Click the rotate button 3 times, or press Ctrl plus or 3 times. This will make wiring easier and keep the circuit neat. For better visibility, you can zoom in and out of the workspace using your mouse scroll wheel. Next, in the same search bar, type Breadboard small. Drag the breadboard small into your workspace, rotate it 3 times as well. Along the sides of the breadboard, you'll notice 2 long rails. The red rail marked with a plus sign is your power rail, and the black one with a minus sign is your ground rail. These are used to distribute power across your circuit. We'll place it just beside the Arduino so that connections are short and tidy. Now it's time to power the breadboard. Click on the Arduino's 5V pin on the left side of the board. When you click a pin, Tinkercad automatically brings up the wire tool. Drag a wire from the 5V pin over to the positive power rail, marked with a plus sign on your breadboard. Once the wire is in place, click the small colored square on the wire to open the color palette. Then, select red to make it easier to identify. While any color works electrically, it's a best practice to use red for power, black for ground, and different colors for other connections to keep circuits organized and easy to understand. Then connect the GND pin from the Arduino to the ground power rail, marked with a negative sign on the breadboard using a black wire. You can either draw the wire first and then change its color, or select the color before drawing. Both methods work fine. These rails now distribute power to all components. You can adjust the shape of a jumper wire by clicking and dragging its corners. This helps you keep your circuit layout neat and organized. Now, we'll connect the Arduino's digital pins to the breadboard. Connect digital pin D9 on the Arduino to breadboard hole J5 with an orange wire. Connect pin D10 to J3 with a green wire. And connect pin D11 to J2 with a blue wire. For the sensors, we need analog connections. Connect A0 from the Arduino to E26 with a blue wire. Connect A1 from the Arduino to E16, also in blue. These will be used for the photoresistor and potentiometer inputs. Let's make sure our components get power. Connect E15 to the power rail using a red wire. Connect E25 to the power rail with a red wire. Connect E17 to the ground rail using a black wire. Connect E4 to the ground rail as well. Finally, connect E27 to the ground rail. Now for the star of the show, the RGB LED. An RGB LED is actually 3 tiny LEDs, red, green, and blue, all packed into a single LED housing. Go back to the Components panel, search RGB LED, and drag it into the workspace. By default, the pinout is set to RCBG. Change that to RCGB. It is a common cathode LED, so the second pin from the left is the ground. The pins from left to right are red, ground, green, blue. Rotate it to match the layout. Then carefully place it on the breadboard with red leg in A5, cathode, G and D, in A4, green leg in A3, and blue leg in A2. LEDs need resistors to prevent them from burning out. Now, search for resistor and drag it in. It will default to 1 k ohms. Click on the resistor, then change the resistance value to 330 ohms. Rotate it 3 times and place its legs on E2 and G2 as current limiting resistors. Since we need 2 more resistors, you can either copy, Ctrl+C, and paste, Ctrl+V, the 330 ohm resistor or search in for another resistor in the component panel. Then place one between E3 and G3, and the other between E5 and G5 for the red leg. Take another resistor and set its value to 10 k ohm and place it between B26 and C27 of breadboard. Adjust the position and use wires to connect. Next, let's add the light sensor, the photoresistor. Search for photoresistor in the Components panel, and drag it to the workspace. Rotate it to the preferred layout and place its terminals between A26 and B25. Since there is no polarity, both terminals are the same. Finally, let's add the potentiometer, which will allow us to change the color. Search for potentiometer and drag it into the workspace. Then, in the right-hand inspector, set its value to 10 k ohms. Rotate the component so that its 3 terminals align perfectly with the breadboard holes at B15, B16, and B17. That's it. Our RGB night light circuit is fully wired in Tinkercad. From here, we can program the Arduino to change LED colors based on the light level detected by the photoresistor, and adjust the brightness with the potentiometer. Let's program the Arduino. At the top right corner of your screen, click the Code button. By default, it opens in block code mode. Change it to text mode by clicking the drop-down in the top left of the code window. Delete the starter code inside. Then, start typing the code for our RGB night light circuit. Set the photoresistor to A0. Set the potentiometer to A1. Define a threshold value of 700. Assign pins 9, 10, and 11 to the RGB LED. Start the serial monitor. Make the LED pins outputs. Read photoresistor and potentiometer values. Print both values to the serial monitor. If the room is dark, check the potentiometer range. Zero to 150 equals red. $150 to 300 equals orange. $300 to 450 equals yellow. $450 to 600 equals green. $600 to 750 equals cyan. $750 to 900 equals blue. Above 900 equals magenta. If it's bright, turn the LED off. Wait 100 milliseconds before next reading. Each color and off action is handled by a simple function at the end. Let's start the simulation. Now, go to the top of the screen and click Start Simulation. If there are errors in the code, it will show up on the screen after clicking Start Simulation. Just check the message and fix the issue, and start simulation again. At the bottom of the window, click the arrow to open the serial monitor. This will show live sensor readings. Initially, potentiometer value will be 0. Rotate the knob using your mouse to adjust it between 0 and 150. As you do this, observe the value on the serial monitor. When the value goes below 700, that's our threshold, the RGB LED turns on. Now that it's on, keep the photoresistor value below 700 and start rotating the potentiometer knob slowly. Watch what happens. RGB LED cycle through colors. When you're done, click Stop Simulation at the top. Congratulations, you've just built your own RGB night light circuit inside Tinkercad, combining Arduino, sensors, and RGB color mixing.